Raz means secret in Semitic tongues, and Ish means Lord in Sanskrit. So I'm a researcher in the Department of Mathematics at Uppsala University. And this is actually part of a big data workshop series called 360 minutes in 525 minutes that is ongoing. And this part is basically about, I guess, empowering every citizen, if he or she wishes, to sort of march towards participatory democracy in the big data age, in the sense of maybe even a legally GDPR defined citizen as a data controller, every citizen. So what is big data age? Basically the volume, which is the amount of data, the velocity, the rate at which data flows, the variety, which is the diversity of the bits, and the veracity with which data flows, is the 4 V's, right? Big data. So what or who is producing big data? People's online activity, machines and sensors, all over the planet now, and more generally, things. So you have what's called the Internet of Things, where the current algorithms in Stockholm's data industry that are in the making are supposed to be predicting in a year or two exactly what level your lettuce rotting ratio is, and reminding you to pick up something as you're close to the right sale of lettuce. So it's so these sensors are constantly monitoring the state of things, basically, and then trying to improve people's lives and optimize things. So where do we store and compute the big data? So basically, Google has been doing this for a while. This is actually Google's storage. It's a farm, a server farm. It's massive, so it's a whole bunch of commodity hardware, typically, and then because the data is so big, it won't fit into a single PC anymore. I mean, this is like within a decade. So now you have to somehow, at the software level, deal with the fact that machines actually physically break as you're computing, because the rate of failure of hard disk is high enough. So you have to, in the software level, account for the fact that machines can fail as you're computing, and that's called fault-tolerant distributed computing. So this is the way to handle big data. Netflix does this, Facebook does this. Facebook has its own centers, but it spills out to Amazon Web Services Cloud to field fluctuations. This is Microsoft's latest dip last year. They're dipping these servers into the ocean bottom because Google was floating it. It's experimenting dipping it and so on. Right? So it's because of cooling. So the big buzz thing is that data is called the new oil. So you can use it to improve processes by exploiting patterns in the data and make something so-called prediction. Right? So the question for us is, how are patterns in data used for prediction? So is making prediction from observation new? Oh, it's pretty old, right? I mean, it's even before humans came around, right? If you believe Darwinian synthesis, right? Because you've seen, I don't know, National Geographic things where the chimpanzee puts a stick inside termite mound, pulls it out, a whole bunch of termites come and it licks it. And that's a learning algorithm, right? Its neural capacity is very similar to ours, so it's not that difficult to appreciate the fact that this being can learn, even if you're sitting on some Judeo-Christian hierarchy of humans on the top, right? So for other organisms, it's possible if you let go a little, right? Because organisms with neurons are easy to appreciate because they have notion of pain, and there's basic evolutionary mechanisms to learn. That's essentially prediction from models, right? So, and of course, within the human traditions, this sort of mathematical prediction is not that new, right? So this is Greek and Indian and Chinese astronomers, and of course the Mayans and Incans were doing amazing things as well. And these are actually, primitive, very sophisticated mechanical prototypes of a computing machine, which is essentially actualization of mathematical ideas in motion. So how do you make predictions from observations? You basically have this basic process. So the way you can go from observation to prediction is via a model. Right? So you have data, which is something you can measure. Right? And then there is a model, and there's a prediction. So we're not getting into the details of how the being that is predicting, which is called an experimenter in mathematical statistics, what sense organs it has, and we're not going into those details. We just say it's recorded up to measures in mathematical sense. Then we can look at this way. So you use data, which is basically your past experience, as a feedback to improve your predictive model. So model can be either non-mathematical in nature, what we do with our brains all the time, right? Making a recipe or whatever, all the time. So I mean, we play with like various kinds of Indian spices on pizzas, for example, Italian herbs in curry. You do whatever you want, right? So mathematically, the models are different. They're usually communicated in sort of classical Aristotelian logical variants, right? Using an axiomatic system. So it's a non-natural language, that is mathematics. And the beauty of that is it's the longest continuously sung song by the humans, right? I mean, because there's no room for misunderstanding. The language doesn't evolve. I mean, language builds on itself. It doesn't mutate like natural languages, which is a very good power of mathematics. And then usually these mathematical models are implemented as computer algorithms, right? And typically in the cloud now, because the amount of data you need to process, as I said, has to be in a distributed fault tolerance setting now. Because every person wants the right thing for them, right? So you have to serve a model individually. So this is basically the little taxonomy of this. How do you make predictions from observations? You have a model, you have a non-mathematical model or a mathematical model. In the non-mathematical model, you have daily models, worldview, beliefs, household chores, even your own personal biases and possibly neurotic conditions that reinforce certain ways of thinking about others. They're all actually daily models. These are called biases and prejudices or whatever you want to say. Multi-generational models are actually very interesting. This is how we have potato today, right? Potato was bred by humans over multiple generations. These are called traditions of experimenters, right? And that's also formalizable in mathematics. Plant breeding, animal breeding, even the Swedish people, I guess your ancestors possibly, who moved through the archipelago over 10,000 years ago, the way they started evolving their herring trapping systems, I just read a little bit. I mean, that's, again, a multi-generational method for going through time because they're life experimenters. They have to live by eating sunlight somehow, right? So constructive and destructive are the two classes of mathematical models from this ethical point of view I'm trying to pitch. And in constructive models, this is Karl Popper's demarcation of falsifiable hypotheses from non-falsifiable ones. That is the definition of a scientific hypothesis. So the beauty of that paradigm is that science can contradict itself in an internally consistent fashion because your instrumentation changes and models can evolve. As long as you say something that someone else can show empirically to be false and fail at the attempt at falsification, it is a valid scientific hypothesis. So feedback from data is crucial for this. It's always improving, and it builds on direct measurements. Okay. Destructive models encode destructive biases and opinions, because destructive models don't have these features by definition, right? So they usually use proxies instead of direct measurements. So these proxies are usually reinforced by biases in the human that's modeling, possibly along with their own motives, right? And then there's no corrective feedback loops with data here, right? And usually they're not transparent because they're intellectual property protected. So this is essentially the problem. So now the nice thing is beliefs, how can we be constructive about this? And here I don't know, I still think this makes some interesting sense. I mean, one of the reasons I moved to Sweden is because it's a monarchy, and because I don't know, they're partaking in the carbon trade with weapons. After Israel, it's the highest per capita GDP earner of weapons, right? But they also take immigrants in the same queue as highly skilled workers. That's the third point. The fourth point I'd like is lagom. It's really built in because I work 1 day a week in Stockholm. I mean, my executives don't make an order of magnitude more than the lowest guy. So I think that's a nice example, at least for a Swedish audience, to concretely show what's a good constructive mathematical model for society. I mean, I already told you, so beliefs could be sexism, ageism, racism, or whatever ism, if you like. And usually these isms are, those in power wanting to maintain it. And that's natural as well. I mean, that's just part of life. So destructive to some part of society is the problem. And encoding these destructive biases and opinions into the mathematical model itself and saying that, oh, the model told me so, the machine never lies. That's a fundamental problem, right? So we have actual mathematical problems with actually making sure that there is actually sharpness to the teeth of this new EU law called, what is it called? Right to an explanation of an automated decision-making procedure. I mean, if a EU citizen goes to the US and Palantir is selling software that is actually going to allow the immigration officer to take random snapshots of some IP-protected algorithm and say that you're actually anti-whoever and actually send you back, you have no way of actually interrogating the basis for this algorithm. So that's a real problem, right? So I'm going to kind of stop here. Basically, these are where I don't know, this is not my expertise. I just read a couple books. And I spent about a year and a half working on R&D in New Zealand. We built software competing with Palantir, which is this big American company. There is 20 Kiwi guys. Anyway, the company got bought out by Aussies, and we were selling software to Interpol and International Criminal Court and so on. So I kind of have some kind of low-level coding monkey experience on what kind of data could be fused by security agencies. So that's more this one. This one is actually very interesting because this is by Cathy O'Neill, and she talks about these specific examples of how models are used to automate life-changing decisions in provably biased ways, And she's actually from the front line. She's a pure mathematician who worked in the finance sector when everything crashed, and she sort of moved around. And she talks about algorithmic trading in finance, universities' rat race for world rankings. This is happening everywhere, right, including Uppsala. So this actually arose out of one publication of US World Reports, US News and World Reports. It's really amazing, the history of what this scoring comes from. Online advertisements, getting a job, performance in a job. All these are silly algorithms. In fact, sometimes they're just like formulae in Excel spreadsheets. And and even if it's sophisticated, it doesn't matter. This one I have personal experience with because I helped with algorithms to do what's called predictive policing. And when I did it, I was so excited, and my daughters were like, "Yeah, Daddy, you're putting criminals behind bars, blah blah blah." And in fact, only after reading Cathy O'Neill's book, recently, I realized exactly what I was doing. So what I was doing is propagating the status quo on the streets of anywhere, say Los Angeles, where you basically mine the behavior of police officers' movements through streets and the burglary rates, and actually, trying to essentially propagate the status quo by saving the amount of gas that's spent and the speed at which the cop should drive, so the visibility. So we did very amazing mathematical models, but what is it in the end? It's going to just propagate status quo, and you don't think about it necessarily, right? When you're just trained to just think, I guess, not properly. So anyway, these are all different examples Cathy talks about. This is a great 10-minute TED Talk of hers, way better than mine for sure. And she really goes into these examples very quickly. And this one, I guess, is sort of my little pitch. So my sort of take on this is we should fight back. And I'm just focusing on just social media, for example. And so this is actually this plug-in to this course that Amelia, who's in the audience, took. And the idea is to help shed transparent light on how we are possibly micro-targeted as citizens in social media. And we want to essentially allow a citizen to basically be a data controller and take charge, at least in the Twitterverse, because everything is public. As long as you abide by Twitter rules and Twitter user rules and developer rules and are GDPR compliant, then you can interrogate your own social media. And it's not doable in Facebook, unfortunately, because of the I agree you sign. Data and Goliath is this other book, which I highly recommend. So this is my sort of security and this type of stuff. He's a mathematical cryptologist, and he's one of these people that looks NSA in the eye and calls them good. So this is a good YouTube plugin. It's a Google Talk. I think, yeah, and then there's another one that's between, yeah, and then there's some mathematical statistics work that's being done because it's very difficult to protect privacy and at the same time bring some utility to the society, because it's like a double-edged sword. You cannot have complete privacy and complete utility, you know. So this is it's being mathematically fought out. And